All right, here's a video going over evaluating function notation with graphs and operations. So I'll be using this, I think, more for the operations part, but let's look at some of our graph problems first. So evaluating functions from a graph, basically it's just, can you read your graph correctly? So here's your function, f of x, and we want to find f of -9. So you go to where -9 is on your graph. So over here, this is where -9 is. And then I'm going to go ahead and go up to where my function is. And I get a y value of 9. So when I go to -9 on my x value, my input, my output is 9. So that would be my answer here. And they kind of do the same like visual as what I was trying to do, right? If I go to an input of -9, my output is 9. For this one, here's your quadratic. So f of 4, here's my function. So I'm going to go to 4 on my input, and then I'm going to go up to my graph, which would be at 3. Cool. Nothing too terrible about those ones. Let's do the piecewise functions ones. This is a nice removable discontinuity we have here. And so they want us to find, here is f of x, they want us to find f of -3. So I go to -3, and then remember, you're actually going to the point on your graph. Now, is an open circle a point? No. You have to go to the actual value, the actual point. So 1, 2, -3, my actual point is at 2. Okay. 2, excuse me. All right, evaluate the function graphically. So same thing for this one. They want to find f of -3. So I go to -3 and I follow until I hit my graph. Still don't hit my graph because this is an open circle. So my actual output is -6. Let's try another one. This one we want to find f of 3, so I go to 3 on my inputs, and then it looks like I want to go down to my graph down here, but this is an open circle, so they don't actually have the point there. Where is the point on this graph at 3? At 3, it's up here, so that would be a y value of 5. Cool. So there's those types of problems for piecewise functions. Now let's do some products. All right, so we have to determine the resulting polynomial. So this one, it has f of x and it has g of x, and then it wants me to multiply them together. So it's going to require a little bit of work, I think. So if I do f of x times g of x, so I'm going to do my 8x plus 8 times g of x, which is -7x squared plus 7x plus 9. Wow, we're going to have to do a lot of distribution here. It's okay, we got this. So let's go ahead and tackle our first term. So I do my first term times every piece in g of x. So then that will give me 8x times -7x squared would give me -56x cubed. 8x times 7x would give me plus 56x squared, and then 8x times 9 would give me 72x. Okay, then I'm going to do the same thing, but I'm going to do it with the second term. So I'm going to do 8 times all these pieces now. Oh, here, I'll do it on the bottom. Okay, 8 times -7x squared would give me -56x squared. 8 times 7x would give me 56x, and then 8 times 9 would give me 72. Now we have to simplify all the way, which means I have to combine all my like terms. So let's see. I don't have any other cubes, so that one's good. -56x cubed. I have a positive 56x squared, and I have a -56x squared. So that will actually, those will end up canceling each other out because positive and negative. So I have 0x squareds. Then I have 72x and 56x. Oh gosh, so if I add those together, I get 128x. Beautiful. And then last but not least, I have just the 72 at the end, so plus 72. All right, let's see if this will do it for us. Whew, good job. They use the box method in their answer. You could also use the distribution method for us as well. So if this makes more sense to you, the explanation does, feel free to use that as well. All right, let's do one more of these because they are a little bit long. So let's see, we got f of x is negative 5x minus 8. G of x is 10x squared minus 3x minus 9. And we're going to go ahead, and I'll multiply my first term times each piece in g of x. So negative 5x times 10x squared gives me negative 50x cubed. Negative 5x times negative 3x would give me positive 15x squared. Negative 5x times negative 9 would give me a positive 45x. Then in the, for the second term, I would get negative 8 times 10x squared would give me negative 80x squared. Negative 8 times negative 3x would give me a positive 24x, and negative 8 times negative 9 would give me a positive 72. And now I can go ahead and combine all my like terms. So I don't have any more x cubes, so I have negative 50x cubed. I have 15x squared and negative 80x squared, which gives me a negative 65x squared. Then I have 45x plus 24x, which would give me 69x. And then I have just a plus 72 at the end. Go ahead and write my answer in there. Negative 50x cubed minus 65x squared plus 69x plus 72. There you go. All right, let's go ahead and do some more arithmetic operations. So these ones aren't necessarily products. They could be other things as well. So this one looks like it has subtraction between my two functions. All right, let's go ahead. What the heck? Okay, go ahead and do this one. So f of x and g of x, and we want to find f minus g. So I'm going to take my f of x function, and I'm going to subtract from it my entire g of x function. So I need to make sure to put that part in parentheses, right? I'm doing f of x minus g of x. You could also see this written as f minus g of x notation-wise. It just means you want to do your f function minus your g function. Make sure to distribute that negative, and then we'll combine our like terms. So x squared minus 10x plus 24 minus x plus 4. I got negative 10x and negative x here, so that will give me, and then I got positive 24 and positive 4 as my like term. So I'll have a regular x squared, negative 10x and negative x would give me negative 11x, 24 and 4 would give me 28. Make sure when it says in standard form, that means they want you to go in decreasing order for your degrees. So like my x squared should be first, then my x, and then my constant. X squared minus 11x plus 28. Beautiful. They could ask you, so here is another way that I was just talking about, how they could write subtraction as this instead. Now they're asking for a product. Oops. So they wrote it as f times g of x, but again, that could really just be f of x times g of x. So either way you see it, it just means multiplication. So this one, let's see, f of x is x squared plus 5x plus 6. Oh, this is just like the ones we just did, x plus 2. So we're going to go ahead and we can do our, oh goodness, first term. They're just in a different order this time. And then second term. And then last term. Okay. All right, so my first term, x squared times x gives me x cubed. X squared times 2 gives me 2x squared. For my middle term, 5x times x gives me 5x squared. 5x times 2 gives me 10x. And then for my third term, 6 times x gives me 6x, and then 6 times 2 gives me 12. So now I just got to combine all my like terms. I have no more x cubes. I have 2x squared and 5x squared, which will give me 7x squared. I have 10x and 6x, which will give me 16x, and then I have just plus 12 at the end. And I just double check, yep, I get cubes, squareds, linear, 1, and then none. So they are in standard form. X cubed plus 7x squared plus 16x plus 12. Beautiful. That one's another product one, but they could also ask you to do like an addition one, so you just have to add your two polynomials together. Okay, so that's for evaluating function notation, graphs, and operations.